Everybody, thanks so much for joining today. I'm really excited to launch our very first video of many to come. Today, we have an opportunity to sit down with Steve Robbins, a longtime friend of mine who specializes in radar technology and has a background in electrical engineering. He really works on the hardware side of things that we often use in a patient care setting. So I was really fascinated to learn more about how radar technologies are working in those environments or have the opportunity to work in those environments. So over the next 30 minutes, we get to talk with Steve and learn a little bit about that. This is a superficial overview and one of two videos. In the second video, we're going to dive in a lot more deep into the details of the technology. I hope you enjoy. Please comment with any questions that you have. Thanks so much. Tell me about a little bit about your background and whatnot.
Yeah, I was always interested in electronics growing up as a kid, and that's what really got me into, that's why I started thinking like, oh, I want to learn how to make this stuff, all the cool electronics like the Walkmans and the video games. And then, as computers got more sophisticated and I just had a real curiosity for how things work. And that kind of drove me into studying that in college. And so I got my degree in electrical engineering. And once I did that, then I started working at places like Garmin and some other places doing design work. And eventually I got into more of a sales role because I'm not a typical engineer. I actually like to talk to people. So, yeah. And so, I got on more of the sales end. And I was in my last job, I've been a field applications engineer supporting hardware for a semiconductor company. But all along, I've just been involved in primarily consumer electronics
Yeah.
for a lot of it, but sometimes also industrial or commercial, maybe a little bit of automotive and aerospace. But a lot of it is like small gadgets that are connected to the internet or have displays or run off of batteries. So that's
Yeah.
primarily what my history is the hardware, for all these little cool toys that you see now, and smartwatches, things like that, cell
Yeah.
phones. Yeah, it's a
I
lot of really
remember
cool stuff.
I remember going mountain biking. Gosh, how long ago was that now? I mean, has it been 20
Oh,
years? Has
almost
it been
20 years. Yeah. Like
20
back in the
years? I
2000s.
I think you had some of the first GoPro type cameras and stuff before they were even a thing. It's
Well,
you know?
yeah. So GoPro I think this is before GoPro, but I was working at a company that was doing a video flashlight. Like they're doing video for law enforcement. So like a smart
Oh,
mirror that would record video. And
ooh,
you probably don't remember that part of it, but I was actually
no,
working at that company when we went on that trip to Moab.
no
And so
kidding.
they had a prototype of a flashlight. It was supposed to be one that a cop would carry, and it had a flashlight in it, but it had a camera in the lens also, so you could
Wow.
record video from the flashlight, if there was an event. And
Yeah.
we had mock-ups laying around the lab, and I thought, well, I'm going to try, attaching it, rigging it up, attaching it to my helmet, and it worked. I went riding out at one of the parks around here, and I've still got the video somewhere. And it's
Yeah.
not great. There was a little bit of problem with it, but then that's when we took that trip to Moab, and I brought that along with me, and and I don't know what happened, but it didn't capture the video for
Yeah.
whatever reason. But it
Yeah.
wasn't actually a real product. It was strictly a prototype that I mocked up.
I remember
Yeah.
it was pretty janky,
Yeah, it
wireless
was.
to get out.
Oh yeah. It was not intended to be a helmet cam in any way.
It's so wild to believe where we've come in 20 years though. Like you had that
Oh
stuff
yeah.
so early on and now it makes me think about computer vision now, and all the
Mhm.
testing that we're doing with AI and
Oh yeah.
computer vision with Google Veo and ChatGPT incorporating their computer vision now. I mean, it's doing some amazing things and it's kind of cool to hear the hardware side of everything and that's why I think it's
Right.
good that we're talking.
Yeah.
Um, and yeah, I mean, to think that those cameras were in flashlights or attempting to be in flashlights 20 years ago, and here we are now, and
Yeah.
it seems like so long ago.
I don't think that
Uh,
ever went to a real product, but it was a cool idea. Maybe somebody did end up making it, but yeah, it was just,
yeah.
but you're right. I was the tinkerer.
Well, and that's what actually something recently I proposed, I think on a blog post or something like that, was how law enforcement is using cameras now. Because the big thing with healthcare and incorporating healthcare, cameras is, I mean, obviously
Mhm.
patient privacy. That's
Right.
that's
Hmm.
what people way smarter than me need to figure out in time is how in the world do we overcome that? Because healthcare is probably one of the most secure or most fearful in in regards to overcoming patient privacy. And so, but I leaned on law enforcement. It's kind of like, hold on, well, law enforcement has done this, right? Like they're recording everything. And so I think that's it's a valid part of the conversation is like law enforcement's done this. They're wearing it everywhere.
Hmm.
If you request access, you can get access through
Hmm.
open means and whatnot. But I think we can learn in healthcare from law enforcement. They have done this, they've implemented it. It's in practice now everywhere in law enforcement.
Hmm.
So if we were going to adopt vision in healthcare, I think it's a good conversation is to say, well, how has law enforcement done it? Does it,
Well, yeah,
you know?
I get what you're saying. There are some critical differences though with those. One of those is that, with law enforcement, that they're expected, like that is the legal enforcement arm of our, what we have for law, right? The
Yeah,
police are the enforcer of the law.
yeah,
And so that's a different situation than healthcare. Now you got HIPAA and privacy, and so there is a legal aspect to that. But if you walk
yeah.
into a hospital, you're not doing anything wrong. That
Hopefully.
hopefully, right. I mean, yeah, sure, somebody could, but
Yeah,
I mean, most people aren't going into the hospital with the intent to do something wrong, and
yeah,
they don't want to have video of them, in a
right.
room in the ER and stuff like that. So,
Yeah.
there is a big difference there. But
Mhm.
you're right, there are probably some lessons that could be learned from law enforcement. But law enforcement, it's not like they capture it, and that is actually specially encrypted video usually,
Yeah.
and it's siloed. So, and we trust the police. Now, that could be abused, and it has been,
Yeah.
but, the videos that you see on the news, those are released by the police. I mean, you can't
Hmm.
just like say, oh, now you can legally request it. You're right. So
Yeah.
it is a different set, but you're right. There's a way to, I mean, there are probably some lessons to be learned from law enforcement,
I
but
think
there
I think
are
like
other, oh, go ahead.
Oh, I was just gonna say like the trial and error part of it, like gosh, it was new to them. So
Right.
there was a lot of learning curves that I'm sure they had to. I just think it's an interesting perspective and some of healthcare we learn from other industries and that's
Mhm.
a good thing to do is to lean on other industries and say, wow, is that something we can adopt? It's like lean
Right.
principles. Lean principles came from Toyota,
Mhm.
and adopting lean in healthcare, that's just thinking outside the box. And that's just kind
Right.
of what I was leaning to it in that.
Well,
Uh,
so there's a technology that I've mentioned to you before, that actually kind of helps with that privacy issue, and that's radar.
yeah.
We've talked a little bit about that before, but
Yeah.
one of the nice things about radar is that you can detect when there's people, and you can even count the number of people, and you can get data about the person, but you also cannot, you cannot identify who a person is. So if you have two adults in the room, you could see like with radar, you could see that there are two adults. You could even see where they're at, how fast they're moving, even
Hmm.
if you can distinguish between whether they're an adult versus a child just based on the size of the person.
Yeah.
And there's a lot that goes into that, but there's no way to tell like, oh, that's John over there and that's Phil over there. There's no way to do that with radar. It doesn't have that kind of ability. So it is really powerful, but it's also very private, which that becomes a real important in things like healthcare. So if
Yeah.
you imagine you've got somebody that is in an accident and they're pulled into the ER and they don't have any way to authorize or give consent for video or anything. They want, maybe it's somebody that's like it's super private and they don't want any video or any identifying information to get out about them. Well,
Yeah.
radar is one of those things where you can do a lot of things with it and it still protects your privacy. So some
Yeah.
of the things,
Yeah.
oh, go ahead. Yeah.
I was
You
just
got
gonna say
questions about that?
I dove into it just a little bit and I read a couple things and I was like,
Hmm.
oh wow, this is pretty cool. And I didn't really know a lot about radar technology and I still don't. So hopefully you can enlighten me a little bit more on that
Yeah.
because but I the one thing that I saw was is that people don't have to wear anything. And that's actually kind of
Right.
neat because if we think about like I thought about my grandmother in her late stages, and I'm
Hmm.
thinking about patients, in assisted living or whatever it may be, wearing something reminds me of those old commercials. It's like, help, I fallen and I can't get up, and they push
Puck.
in a
Yeah. Like the
button. But
little puck. I've
yeah, but
fallen and I can't get up. Yeah.
yeah, I mean, I think they still regurgitate those old commercials too, which is kind of funny. They haven't recorded any new ones. It's like I'm like, that looks like 1980, and it probably is.
Yeah.
But I think that's kind of neat. And so it's like, but I haven't seen it. I haven't seen radar yet, but it
Hmm.
makes me think of like, okay, if you don't have to wear anything, like how to
Hmm.
hospital or how to, assisted living or hospitals incorporate that into their kind of their structure and so forth, you
Right.
know? Um,
Well, and it's still really early on, but I've actually talked to companies that make medical equipment, and I won't go into details to protect their privacy and their
yeah, yeah,
IP.
yeah, yeah,
And I'm not even going to mention who I used to work for, but I was actually a specialist in radar, and I was promoting this technology to companies to get them interested in using it, and they
yeah,
were very interested. I just think it's still so new, and people have a hard time wrapping their minds around it. But it's going to eventually be adopted, and you're slowly starting to see more and more companies use it for other applications like, occupancy detection for, HVAC systems in a home or security cameras. They'll use radar, and it's more robust and reliable than infrared. Most infrared detectors, you see like, you have a light switch that has a little dome on it or a little,
yeah,
translucent part on it. Those are what they call PIR, or they're infrared,
yeah,
and those can be fooled. So I actually had one in my house. I put one in my house, and it started turning the light on at random times. And I was like, what is going on? And it turned out what it was is I have a heat vent above the light switch in my bathroom downstairs. And
yeah.
when the heater would turn on, it would blow a wave of warm air down in front of that, and it would turn on the PIR switch, and the light would come on. Well, you
Yeah.
don't want that. I mean, it's and plus it looks ugly. People complain like, "Oh, you got that dumb little, lens on there," and kids will poke at it. I've had some consumer electronics companies say like, "Yeah, we get a lot of returns because, kids think it's a button and they push on it and it damages it." So
Oh, okay.
with radar, it's not fooled by the heat waves. It's very robust. You can hide it behind a piece of plastic even, so you don't even know it's there. It's great for security for that reason. But
Yeah.
also, I was thinking about this for healthcare, like if you have it in a hospital room or something or a clinic,
Yeah.
um, if a patient sees a camera or some sort of sensor where you have to have a lens or a port or something, then that can make them nervous because they're
Right.
like, are they watching me? What are they gathering? Is there a microphone? And all these thoughts. Not everybody thinks that, but some
Yeah.
do.
Yeah.
But with radar, you can actually hide it completely. Nobody will even know it's there. It's impossible to know it's there.
Mm. Mm.
And so you can do things like like I said, detect where a person is, how close they are, how fast they're moving. And one really cool thing about radar is that you can even measure heart rate and breathing rate. We've
Well,
done it.
that's
Oh, yeah.
incredible.
And
Yeah.
it's remote. There's a company that uses the technology from the company I worked at. And they actually have in production a radar system to measure heart rate and breathing remotely, like
Wow.
from a couple of meters away. And we've
Yeah.
done it ourselves.
Yeah.
So, getting some vitals detection. And
Hmm.
also that helps you determine, is this a person or is this just like a box,
Yeah. Does
No,
the box
seriously,
have a
you
pulse?
can, right. Well, I mean, so you can detect like, is there an object there with
Yeah.
radar? But
Yeah.
the nice thing is you can actually tell like, oh, it's not just an inanimate object. There's actually a heartbeat there. There's a breathing
Yeah.
rate there, and you can tell it's a person. And for medical applications, you can tell that maybe their heart rate's elevated, or
Yeah.
maybe their breathing rate's elevated. So you can actually capture vitals with it as well.
Well,
Um,
that's really cool
yeah.
because I think the less things that people wear,
Hmm.
obviously the better. I mean, it's like,
Right.
I've worn pulse oximeters and things like that, and it's like I couldn't imagine wearing it for days on end. And then in assisted living, clearly, like people are mobile, people are doing things,
Right.
people are up and walking around, and I think that the sensitivity of radar is where the opportunities come in because falls with
Hmm.
elderly patients, I don't even know the statistics off the top of my head, but it's extraordinary and it
Yeah.
costs
Yep.
a lot of money. And going into a personal, I think I don't know if I shared with you, recently I went to my aunt's funeral. She was a pediatrician for many years and
Mhm.
kind of a big inspiration for me, and helped raise us as kids. She fell and broke her hip, and that
Hmm.
was kind of the the end, or heading toward the end, and that's really
Right.
common in elderly
Oh
people.
yeah.
Falls. I mean, it's probably one of the leading reasons that people, head toward their demise because
Hmm.
and my uncle who's cardiothoracic surgeon, he even said, when he's talking about his sister, he's like, it's almost like the classic. He's like, somebody falls, they break their hip, and then unfortunately they
They go
don't.
downhill from there. Yeah.
Yeah, they go
I've heard the same
downhill.
thing talking to these medical companies. They say there's fall detection and elder care is a very quickly, it's gonna blow up. I mean, there's like
Yeah,
the need for and the number of people that they if we didn't have technology, then there's not enough people to take care of all these people, frankly. And
yeah.
we, by the way, you mentioned fall detection. We were actually working on a prototype algorithm for that
Mm,
specifically. So radar can be used for fall detection as well,
yeah.
not just determining. And we've talked to there's companies out there working on that as well. So if you add that, in an elder care situation or even in a hospital or whatever, it takes the burden off of the staff and they can focus on other things, and you probably don't need as many people to begin with, which is going to be important because we don't have enough people that are going into those fields.
Yeah, yeah, I mean, I think the healthcare shortfalls right now are just, exponentially growing.
Hmm.
And, that's one of the things that I focus on is efficiency and AI.
Hmm.
And, I'm really interested, and I don't know enough about it. You talked about algorithms, and artificial intelligence is driven a lot by algorithms. And I'm
Hmm.
wondering if these radar sensors, there's something that they can do utilizing AI. I don't know
Oh, absolutely.
where that joining or collaboration can occur. But if radar is
Yeah.
tracking data and movements, I
Hmm.
would think that there could be some sort of predictive analytics in there
Right.
too, to highlight like risk factors and things like
Right.
that. And AI can kind of do that. But I don't know what you know about that kind of stuff.
Well, so it's funny because one of the struggles that we had, so we were selling the hardware, right?
Yeah, yeah.
We weren't selling a complete solution. We didn't have, so every radar application is a little bit different, and so that drives the need for algorithm development for that radar system. And the problem is it's still so new and it is very complex, these algorithms, and very sophisticated, that there's not a lot of people out there that know how to do that stuff.
Hmm.
And so it was a struggle getting adoption in the marketplace. And I had lots of customers, talking about like, oh, we'd like to do health, like vital signs monitoring, people counting, presence detection,
Mm.
fall detection, for hospitals and for elder care and, assisted living places.
Yeah.
Um, we talked to a lot of OEMs that were doing that, but they would always end up saying like, well, can you provide us the algorithm? And we didn't have the resources to do that. Okay.
Yeah. Yeah.
Now there are people out there that know how to do that. And the company I was working for, they were also they also acquired another company that was starting to do I wouldn't really call it AI, but it's more machine learning. It's
Yeah.
not as sophisticated as full-blown artificial intelligence, but
Hmm.
it is still, like analyzing the data and using some neural network processing to be able to more effectively process that data. And we were working towards moving towards providing that to radar customers so that they can more effectively know what's really going on. So I absolutely think that's going to be the future of radar. Like you're going to really need some of that to really accurately make use of it. It's going
Yeah.
to make it whole lot better. So as you know, I think that the hardware is there now, actually. It's the algorithm and the machine learning and the AI. I mean, you could use AI if you port all the raw data out to the cloud and use AI, then yeah, you could do that as well. But
Mm.
not every system's going to require that would require internet connectivity, of course.
Yeah.
And
Yeah.
you
So,
have things like edge processing where you do all the processing right there in the device, and that saves a lot of extra cost.
yeah. So, as far as like the transmission goes, so if you have a
Mhm.
sensor in a room, for example, how are you connecting? And I don't know if it's been looked at as far as like de-identifying. So, some way there's got to be a patient assigned to that, right? So,
Right.
is that more of like the EHR or the hospital or the healthcare
What's
organization to
EHR?
electronic health record? And
Oh,
so
okay, okay. Yeah,
Epic or Cerner or things like
gotcha.
that.
Yep.
So, I guess like the how that information. So you have a radar sensor, right? We've got
Mhm.
that in a room, and that needs to be transmitted to a chart of some kind,
Right.
right?
Right.
Or a nurse at a monitoring station needs to be able to see this is so and so.
Right.
How I guess is that information de-identified and what, or is it, or is that really the responsibility of the IT teams on the receiving side of things?
Well, it's not really the IT team that would be doing that. It would be on whoever's designing the system itself.
Hmm.
Now, you asked like, how does the data from the radar get to the rest of the system? That could be a
Yeah,
number of ways. I mean, you could do wired, like Ethernet, USB, something like that.
yeah,
Um, it just depends on what's practical. Like if the system designer knows that these are only going to go in brand new buildings and they can add the wiring in the wall ahead of time
yeah.
and rewire it, well then Ethernet and USB are going to be really reliable, low cost solutions that are going to have high bandwidth, and you're not going to really run into issues. But for retrofitting a hospital that with new sensors,
Hmm.
which is going to be a lot more common, now it's going to make more sense to start looking at wireless things like Bluetooth, LoRa, Zigbee. There's a lot of wireless protocols out there,
Yeah.
Wi-Fi. Those are what you would use to actually transmit the data, and it could be, and where you do your processing could be at the sensor itself. What I was talking about earlier, where it's edge computing, and maybe you have because there are microcontrollers out there now that will do machine learning, and they're very low power. You could have a little battery powered device, and it could do the algorithm processing and come up with a answer like, oh, there's somebody here, if that's what your question is.
Yeah.
Or if you're measuring heart rate, let's say, it'll process the data and extract the heart rate, and then that can be transmitted over wirelessly. Or you could transmit the raw data, although that's going to be a lot more information.
Yeah.
The raw data could be transmitted over a connection back to your main system, and there'd be a hub of some sort. And then you could either do processing at that system, or if it's cloud connected, you could actually run it back to the cloud and process it there. So
Hmm.
there's a lot of different options there, and
Yeah.
the system designer, the system architect makes the decision of where certain functions are, and there's no one right answer for any application. A lot of it depends on, like, is this like is the infrastructure there already? Like, is it a
Yeah.
new building? Is it retrofitting? Are these running off of batteries, or they're line powered? And how sophisticated are the algorithms? So all
Hmm.
those questions really need to be answered, and then the system architect figures out like, well, the processing goes at this stage, and this is where the sensor is, and it's battery powered, et cetera. So
Okay.
it's a lot of flexibility there. So there's not really one answer for that.
Yeah, because I'm thinking of like a radar system in like so many different environments, right? Even in the home
Hmm.
environment. Like
Oh yeah.
what if somebody's wants one in the home? Like they're concerned about my neighbor, wonderful family, and
Mhm.
but they have caregivers, and
Yep.
it's kind of like, gosh, like there's no I think actually my neighbor fell, and I think he was on the ground for like 48 hours,
Oh
and
wow.
yeah,
Yeah.
and this was last year, and he had to go to rehab for a couple weeks and all this kind of stuff. But like, I thought, well, my thought was, why didn't you come get me? His wife,
Hmm.
they didn't want to burden me and these types of things. I'm like, gosh, if they
Right.
had that type of sensor in their home, like
Hmm.
somebody could have been alerted, right? Whether it's
Right.
family
Right.
members or
Yep.
whatever it may be. And I think that there's so many different opportunities. And as I think about all my years at a bedside
Hmm.
therapist, turning patients. So wound care is another thing too that we see as a potential opportunity, because there's protocols that are involved with moving patients every so many hours, and it's turning patients, a quarter turn this way, quarter turn that
Oh
type of thing,
yeah.
to avoid pressure injuries and things. And pressure injuries are extremely costly to
Yep.
hospital organizations as well. And so right now we're using like pressure sensors, and they're so, right? It's like, or we rely on scheduling. And it's like,
Hmm.
and it's a burden for, I think, a lot of the bedside teams to say, oh, on this hour I got to go turn on this hour, and then remembering,
Hmm.
did I turn them? Did they self turn? Because the
Right.
self turning is really hard to monitor, right?
Right.
Like
Oh yeah.
and I remember reviewing that with a team, and a lot of the nurses said, when they self-turn, what do we do? It's like, but I think with radar technology, that could actually help monitor that too, and it could actually
It
record those
could. It's
processes.
going to be
You
more
know?
difficult because, you're not going to be able to it that's kind of like on the edge of what's possible with radar.
Yeah,
Now you mentioned pressure sensors because I've actually talked to companies that do that, and they were
yeah,
like, and what the way those systems work is that you'll have bladders in the bed in
yeah,
the mattress, and then you
yeah,
have a number of bladders, and then each bladder has its own pressure sensor, and so you can tell when somebody rolls over.
yeah.
Now, what might be now, are you saying that the downside is the fact that you're not getting accurate information there?
I think the pressure sensors are very rudimentary in their current
Hmm.
state,
Right.
which is that they're just monitoring whether or not somebody is in bed. They're not
Right.
determining
Yep.
angles and rotations and things of that nature. Now, there's some beds that you can program to actually rotate patients in the critical care setting and whatnot.
Hmm.
But I just think that, you mentioned, prior to this, how the sensitivity of the radar. And that's what I
Hmm.
was wondering is that can it monitor somehow positioning? Because if it was able to detect positioning, I think that would be well adopted in the healthcare environment, particularly in acute care, not
Yeah.
necessarily in a home environment and whatnot. But I wonder how that and I'd have to know more about the sensors and their capabilities to
Hmm.
understand that. Um, but yeah, I just think that if it could monitor positioning, I could see ICUs and so forth just gobbling that up
Yeah.
right away.
That's going to be a much harder challenge. Now, I
Okay.
think theoretically, a radar system could be made to do that. You're probably talking about a very advanced radar system,
Yeah.
though,
Hmm.
because you have with radar, when you start getting into measuring, angles, like where a person is
Yeah.
in a room, because it's not just how far away, but also the angle. Is it
Mm.
straight on or is it off to the side? That requires additional what they call, transmit and receive antennas.
Okay.
So the sophisticated radar systems out there that can measure angle, you have multiple transmits and multiple receives for the really advanced ones. And the more you have, the more fine of information, the granularity improves. And so you get
Mm.
like smaller bits of information, if you will.
Yeah.
And so with that, eventually you could get enough transmit and receives to be able to piece together like, oh, here's the position of the person.
Hmm.
The hardware that we were selling didn't have enough of that to be able to get that kind of granularity, but theoretically you could at
Okay.
enough where you could measure that.
So what?
Now,
Yeah.
well, I was going to go back to your pressure sensor thing, though.
Yeah.
I'm aware of
Yeah.
the companies that they have one bladder and one pressure sensor,
Yeah.
and then you can tell if somebody's in the bed or not, right? But
Hmm.
what I was talking about with a couple of these companies were, like having multiple bladders, and each bladder has a sensor, so now you can aggregate all those together, and you could actually tell then, is somebody moving, and possibly even are they turning over? Because they did mention that, by the way. They said, this is something that has to happen. They get hot spots and they need to be
Yeah.
turned.
It's
Right,
it's it's a big, big issue, and I think that you know both sensors combined sound like it's a really,
right,
really encompassing technology, right? And
right.
so
Well,
that
that's where I was kind of leading to is that maybe you use both in the
yeah.
system, and that would allow you. And there's a concept called sensor fusion, and that's
Oh,
where you use more than one type of sensor, and you can
okay.
get much better results than either individual sensor. Like it's not even like 2x, it's like 4x, 5x. It's like significantly improved when you
Yeah.
combine two different types of sensors.
Well, I
One
love
quick.
the
Oh, go ahead.
I was gonna say I love the non-invasive aspect of all of it
Yeah.
too, because that's really where I think things need to end up being. And there's a
Hmm.
lot with laboratory data and laboratory, testing now and stuff that doesn't need blood draws and things. And I think,
Hmm.
both of what we're talking about are non-invasive, and so that's a good thing. But
Yeah.
I was gonna ask you, what is like so being in sales, and what are some of the barriers that you hear? You're developing the hardware side of things,
Hmm.
right? And then you're approaching different companies or whatnot, or have a pulse on industry. Where are the barriers for adoption
Well, I
of?
mentioned it earlier, and it's really the algorithm development, the
Okay.
technical understanding of how to develop the systems. And we had some people at the company. We just didn't have very many people that had the know-how to be able to develop these algorithms. And we're talking hundreds of customers, all
Yeah.
across the U.S. and well, really North America.
Yeah.
Somewhere up in Canada and even down in Mexico too. And these companies, they're really interested, but they don't have the expertise, to be able
Mm.
to develop these algorithms. And even though we have a few people, they're already, I mean, they're talking to the biggest customers and, like, I won't mention any names, but
Yeah.
you've heard of some of these, like
Yeah.
really big names. And these big names are using radar. And so we are helping them.
Yeah.
But we can only do so much. And so
Right.
that's really been one of the biggest limiting factors. With radar, people initially might look at cost as like, well, it's more expensive than PIR, the infrared technology I mentioned,
Hmm.
or a pressure sensor. Um, and yes, it is a little bit more expensive, but some of the simpler radar systems are actually getting down to the point where it's not that much more, and the benefits that you get with radar can the improved data that you get, the robustness, the
Yeah.
reliability of the data is much better, and so then it makes sense to spend a little bit more and do a radar system.
Well, I think
So
that,
cost was kind of a little bit of a
yeah,
barrier, but that's changing very quickly. And
the
so will
the
the
costs.
algorithms will help too,
I think the
especially with
costs would
machine learning
be
and AI.
quickly offset if you
Mhm.
have earlier detection and better if you have the proper algorithms developed. I mean, a prevention of one fall. I mean, that would be
Hey, you should
massive.
get into sales then. Well,
Hey,
so I mean, so like you're absolutely right though. You look at we call it total cost of ownership,
yeah,
right? And so there's support, there's sales support, there's extra benefit to the end user, right? And those are all, like when we had a lot of times I'd be talking to the engineers at these companies, right? And they're
yeah,
focused on like, well, we needed to do this thing and this is how much money I can pay for it. And so what you're talking about though, you're absolutely right. Like what if it saves a fall and whereas another technology might not, wouldn't it be better to spend more money and prevent that fall because it's a liability issue? So it's people like probably higher up at these companies, like a VP level or somebody like
yeah.
that really would see that overall picture. But you're absolutely
Mhm.
right. That is a real benefit. And when you're just talking to the design engineers looking at the hardware, they don't always
Yeah.
think of it that way.
Yeah, I think that, one of the big things in healthcare too is always studies, right? Is
Yeah.
comparative studies. And I think that the end result too is wild is we talk about a lot about prevention and everything, but the end result in healthcare is always mortality, which is kind of crazy because you think of like all the other benefits that are there, cost savings and whatnot.
Mhm.
But physicians focus a lot on mortality. And if there's no change in mortality, then a lot of times it's really hard to adopt some of the technologies, or
Yeah.
even pitch the technologies. If I say, hey, this drug is better than this drug, and they're like, well, what's the difference in mortality of
Hmm.
utilization of that drug? If there's no change in mortality, a lot of times it's a wash, even though you have reduced time on this or better feeling about this or whatever it may be. But I think that that's where,
What if it's a chronic condition that's caused by it versus not? So like, quality of life could be vastly different from one to the other. Are they taking that into account?
it's tough is that we want to, right? I think a lot of
Yeah.
people do, and I think it's measured. Quality of life is
Yeah.
measured on
Right.
a lot of
It's
medical
harder to measure,
interventions.
I'm sure.
It is, and
Because like mortality, that's easy. It's like a one or a zero, right?
yeah,
Either you're dead or you're
it's
not.
it's it's
It's
pretty much
digital. It's
it's pretty
binary.
much analog. Yes, it's like
No,
one
no, it's actually digital.
or
Because it's
digital.
like,
Yeah, yeah.
yeah, yeah.
So, but I think that it's hard because when we talk, as a background in respiratory, we talked about
Yeah.
ventilatory days and whatnot. Like, hey, they got off the ventilator, a week earlier than if they would
Right.
have if we had done X, Y, Z.
Sure.
But then the physicians would turn and say, or data scientists or whatever it may be, well, did this change? Did this change
Hmm.
the outcome? And a lot of times the answer was no. And I'm like, oh my
Hmm.
gosh, like, but so that's different levels of thinking though. Is that we
Right.
look at because we can tie costs to a lot of this, right? If somebody comes off, for
Well,
example, a
yeah, but if you're
ventilator,
going to spend, like if you're going to have a system that costs twice as much and they only gain a week of life or something like that,
yeah,
then that's probably not a wise investment. But if you're talking about $1,000 is the difference between being able to walk and live a normal life and being confined to a wheelchair the rest of your life. Now
Yeah.
you're talking about something completely different.
I know, and that's the deeper level of thinking that I think
Yeah.
healthcare strives for.
Hmm.
That outside the box thinking too, and really showing the benefits. I think of radar technology and so forth.
Hmm.
If it was initial cost was higher, but you had all these other factors, I think that's where responsible administrators would say, what is more valuable.
Yep.
And if there's a return on investment, I think that's another good thing to measure. But what's the thing that excites you the most about radar? Because I think it's cool. I want to dive into it a little bit more,
Oh
in
yeah.
time. But I think like if you're looking at the future of it, where do you
Yeah.
think that it's the most beneficial and what excites you the most about it?
I just think there's so much potential to make um, and I mean, there's things with healthcare, which I've already mentioned, being able to effectively care for people without having to hire a bunch more people, right? So having assurance, and you mentioned in the homes, that's going to be important. It's going to start with like assisted living places, elder care facilities,
Hmm.
hospitals. That's where it's going to start. You're going to start seeing radar be adopted first because they can absorb the extra cost that's going to go along with those sensors and the infrastructure that's going to be needed. But eventually the cost will come down, and especially as you get economies of scale to where now you can start thinking about like, oh, we can sell it to people to use in their home. Because if
Yeah,
you talk about in the home, well, first it'll probably end up being like some if it's Medicare, Medicaid covered or what covered by
sure,
insurance, then it
sure.
could be more expensive. But even then, later on, as the costs continue to come down, then you could get to where it's like now it's a over-the-counter purchase. You could go down to your
Yeah,
Best Buy or whatever, get it on Amazon. You could put it in your house, and that's going to give people a lot more peace of mind long
yeah,
term when it comes to healthcare. And you're worried about your parents, living in their house by themselves. I'm actually dealing with that right now. My parents are getting the age where they're getting ready to go into some sort of assisted living
yeah,
because my mom has dementia and my dad is not very mobile and he's forgetting a lot of things and they just can't take they're not going to be able to take care of themselves much longer.
yeah.
So it's a
Well,
real problem for a lot of people.
let's keep the conversation going. I think we're running out of time, unfortunately.
Okay.
But yeah, let's set up another time to meet. I think it'd be awesome. And
Okay.
thank you so much for joining today. I appreciate it.
Yeah. Yeah.
And yeah, great
Good luck with
conversation
the
starting.
podcast. This is exciting.
Hey, thanks,
I
man.
love it.
I appreciate it. All right, we'll talk
Yeah.
later.
All
All
right.
right. Thanks, Steve. Bye bye.
Yeah. Yeah. We'll see you.
All right.